All right, this is going to be our first attempt at a video demonstrating how to solve a problem using the Lightboard Studio here on campus. And so what we're going to do is I've got this problem. I've got a car moving at a constant velocity of 20 meters per second, and that car is going to launch off of a cliff that's 40 meters above the ground. And so that launching angle is 0 degrees. The car is going to launch with a horizontal velocity of 20 meters per second. And what we want to try to find out is how far from the edge of the cliff is this car going to land on the ground below. Now this cliff is 40 meters above the ground, and so this is inherently a two-dimensional motion problem, right? There's the object's moving, in this case, to the right, so in the x direction. It's also moving down, so it's moving in the y direction. So we've got a two-dimensional motion problem here. We're trying to figure out something about the x motion. So how do we even begin to think about this? So the first thing, often you'll have a word problem, so the first thing will be to draw a picture and begin to really visualize what's going on. The second thing that you want to do is you want to basically catalog all of the things you know. So this is what we did with 1D motion. It's probably even more important now to do it with 2D, because basically you've got two sets of parameters or quantities to keep track of. So the first thing I'm going to do is I'm going to write everything I know about the x motion, right? This is an x motion problem. Even though it seems like a 2D problem, maybe if I just write out all of the x motion things I know, I'll be able to solve the problem without even worrying about the y motion. All right, so let's focus on that first. What are all of the x motion quantities or things that I know? Well, first off, we're launching from the edge of the cliff, and I've called that edge of the cliff the 0 point in my coordinate system. So the initial position for my car is going to be in the x coordinate, 0 meters. Now, my initial x velocity, well, we're launching off the cliff at a speed of 20 meters per second, and that velocity is entirely in the x direction. And so to the right is positive for me, so my initial x velocity is plus 20 meters per second. What else do I know? Well, once I leave the cliff, I'm going to be in free fall, and we know in free fall that the y acceleration is going to be 9.8 meters per second squared downward. And this means that my x acceleration is 0. So I'm not going to have any x acceleration. What else do I know? X final? I don't know that, but that's basically what I'm trying to figure out. Right? We're trying to figure out how far away from the edge of the cliff are we landing. So I think that's pretty much all I know. And so, again, let's ignore the fact that we are aware this is a 2D problem and we're going to need to use 2D information. Let's just say we're asking about x. Let's just see if we can solve for x immediately. So we're looking for position information, and so I'm going to go ahead and write down one of our kinematic equations, and let's just follow what we know, what we've got, and let's see if we can solve this problem without doing anything more than what we've already done. So we know this quantity, this is 0. We know v initial, this is the plus 20 meters per second. We know ax is 0, and so this term's going to drop out, this term's going to drop out. So my x position, so at any time, I can figure out the x position of the car if I multiply my 20 meters per second velocity with however long I've been traveling, so t. And so the question is, do I know the time in which I'm in the air? And unfortunately, the answer is no. We don't know the time. If we had the time, we would just plug it in immediately and we would be done. And so we're stuck, right? We know we need to find this final x position. We go about it in a 1D manner, and we get stuck. And so it's at this point that we realize, okay, since we can't solve this just with x information, we're also going to have to look at the y motion, right? And this is sort of like the essence of all of our 2D motion problems, is you start the problem, get stuck, and then move to additional information to try to incorporate to get unstuck. So what do we know here? So our y initial position is plus 40 meters. That's because I picked the ground, not the cliff, but the ground as my 0, so that means I start plus 40 meters above that. What's my initial y velocity? Well, my initial x velocity is plus 20 meters per second, but my initial y velocity is 0 because none of that velocity has a component in the y direction. What's my y acceleration? Well, again, we're in free fall, so I've picked up to be positive, so our acceleration is going to be minus 9.8 meter per second squared in the y direction. And then our y final value is 0. So I think that's everything I know about the y motion. And so let's go back to our kinematic equation, and I'm going to write out the exact same kinematic equation that we started with above. The only difference is I've swapped my x variables for my y variables. And so now I have an expression with t in it. Is it possible that we know enough to be able to solve for t in this expression? Well, let's see what we know. We know the final position, we know the initial position, we know the initial velocity, and we know the acceleration. And so, yeah, the only thing we don't know in this expression is time. All right, we're going to be able to do it. So what's our final position? 0 meters. Our initial position, plus 40 meters. What's our initial y velocity? 0. All right, so this term is actually going to drop out. And then plus, so 1/2 times minus 9.8 meter per second squared is minus 4.9. And so I've got this term and this term, and so I'm going to rearrange. So I've got plus 40 meters equals minus 4.9, equals plus 4.9 meter per second squared, t squared. And so now I'm going to solve here for t. So I don't have a calculator on me, so I'm just going to divide 40 by 5. So this is about, so t squared is about 8 seconds squared. And then I'm going to take the square root. So t is about 2.7, 2.8 seconds. So that's the time that we're in the air. Notice that time was entirely determined by the initial y velocity, the initial y position, and the y acceleration. So this is what we mean when we say that in two-dimensional motion, the motion in the x and the y is independent. So the time we were in the air, entirely determined by these y parameters. So once we have this time, we can head back to our initial x expression, and we can solve for the final x position. So we've got 20 meter per second, now multiplied by 2.7 seconds. So our final x position is about 54 meters. And we'll throw in the plus sign there to tell us that we're 54 meters to the right of where we started, so 54 meters from the edge of the cliff. Now, again, this is the general approach to our 2D and really all of our motion problems, right? You start investigating, trying to solve for the quantity of interest, you get stuck. Then you incorporate more information in the problem to try to solve a different problem. So in this case, we were trying to find the final position. We got stuck, realized we need to find time. Then we solved the y motion to find the time, and then plug that back in so that we can find the initial thing that we were looking for. All right, so this is hopefully the first of many little demonstration videos that I'll be able to put together to kind of walk us through how to approach a problem, how to think about setting up a problem, and then how to move forward when we get stuck, right? When our first plan doesn't work out and we've got to come up with an alternative plan to solve whatever problem we're trying to solve. All right, thanks.